Hey everybody, this is Mr. Munson. We are in Unit 7, right triangles. Uh, I know that I say this a lot. I do say that certain sections are my favorites, or some of my favorite. This Unit 7 is probably, for sure, my favorite, top of the list favorite section. And the reason is because we learned trigonometry in Unit 7. I love trigonometry. The reason is because we get to use these three keys on your calculator: sine, cosine, and tangent. And so it's for the very first time, but it has a really cool application in our real world and can simplify things. I use these trig functions in my everyday life specifically to find certain angles or even sides. It's the first time that we have a function, an equation that allow us to find either an angle or a side. We have no other equations right now that allow us to do that. And so trigonometry brings that in. All right, let's go ahead and get started. So here's your quick list of I can statements. So at the end of this video, you should be able to simplify equations using radicals, making sure that you're following the correct form. Now, I'm not going to teach that. I put that together in a different lesson, a different video. So if you're having trouble with reducing radicals, as I do them today in this lesson, you need to depart from this video and go watch my reducing radicals video. For some of you, you'll understand how to do it with me. I can identify and right triangles and its parts. I can use Pythagorean theorem to solve for a missing hypotenuse, Pythagorean theorem to solve for a missing leg. I can apply the converse. Most of the stuff that's in this particular section, 7.1, we've done before, but some of it's new. For instance, the last one is I can write and state the three trig functions. At the end of this video, when you come to class, next class, you need to be able to say, I know my trig functions. Sine of theta is equal to this, cosine of theta is this, and so on. And so let's go ahead and get started. Make sure you can do that when you come into class next time. All right, so we're going to start off with all of our vocabulary words. And so if you stop and go to the description part of the video down on YouTube, just underneath the video when you came to it, you'll see that there's a link and you can download this Chapter 7 vocabulary sheet and print it up and then write your vocabulary in it. Now what I'm going to do is I'm going to display all the vocabulary words today so you can write them all in, just put it on pause, write this stuff in. But we're not going to go and use every one of these vocabulary words. They'll come up at another time. So I'm just going to quickly display them, but I'm not necessarily going to walk through them. You copy word for word what I've got there, because in this unit we're going to start having vocabulary checks. And when I ask you, hey, what's an adjacent leg, you need to use the words I give you. Okay, so you sometimes I use an abbreviation. If the abbreviation doesn't make sense to you, then you write it out in full words. Let's get started with this vocabulary. So as you can see, Pythagorean theorem is a couple of lines down. We're going to look at that one. Pythagorean theorem is a squared plus b squared equals c squared. You need to know which pieces are the legs and which part is the hypotenuse. Sine, cosine, and tangent are three equations that we need to know. So again, at the when you come to class next time, you'll need to be able to write these equations exactly. Okay, so you won't have to be able to use them. That's really important. And at the end of this video, you just need to know them and how to write them. We'll in another section learn how to use them. Okay, so the part that you need to know is this part right here. But go ahead and write down all the vocabulary so that you have it. Put me on pause because I'm moving this screen. Inverse trig function. Geometric mean, go ahead and skip that. Opposite leg, we won't need that today. Adjacent leg, we won't need that. We won't need the 45, 45, 90, 30, 60, 90. Angle of elevation, angle of depression, none of that today. So really the only thing in today's lesson that you'll need to understand the words for is leg, hypotenuse, and Pythagorean theorem. And those are all stuff that we learned in a previous time. But go ahead and copy this down so that you have available and you've taken care of it tonight. Okay, so I'm going to do some simplifying radicals. Again, I'm not going to go in great detail. Matter of fact, I might go pretty quick in this for your taste because you don't know how to do some of this stuff or you've forgotten it from last year. And if that's the case, then you need to put it on pause, put this video on pause, and go watch my simplifying radicals video. Well, we're going to simplify square root of 16 very easily. That's 4. okay, because square root of 16 is 4. 16 is a perfect square. That's cool. Square root of 45, I'm going to set up two radicals. I know that 9, which is a perfect square, goes into it. So I'm going to write it as 2 radicals, square root of 9 times square root of 5. When you multiply two radicals like that, they end up being put together in that form. So I'm breaking it up. Square root of 9 is 3. And square root of 5. There's that answer. How about square root of 180? So I'm looking for perfect squares that go into that. Well, I know 9 goes into 18, so it's got to go into 180. So 9 goes into that times 20. So I can simplify that. Square root of 9 is 3 square roots of 20. Now some of you are going to walk away from that problem because you've reduced it. And what I'm telling you is don't. The square root of 20 still has another perfect square in it, and that's 4, so I'll write it as two radicals like that. Square root of 4 times square root of 5 gives me that square root of 20. Square root of 4 can be simplified to be in a 2. So then I end up with 3 times 2 is 6, 6 square roots of 5. Okay? All right, let's take a look at another one. This one's breaking a rule. You're not allowed to have radicals in the denominator. So I'm going to multiply by what I call my special 1. Whenever I take a number, and this is a number, and I multiply it times 1, it gets that number. Now, it might change the look of it, but it's still the same value. It's still worth the same. So this right here represents my special 1. Any number divided by itself is 1. So I'm taking that special 1 and I'm multiplying it. And so what ends up happening is I have 3 square roots of 5, and of course this right here, square root of 5 times square root of 5 is the square root of 25. Square root of 25 is 5. Okay, so that's reduced. I'm just going to take a real quick calculation of these numbers outside the radical and make sure that they can't be reduced anyway, like fractions typically are. And there's no factors between 3 and 5 that are common. The 5 that's on the outside here and the 5 that's under the radical, sometimes students try to cancel those things out. They can't. The 5 that's underneath the radical is what I call is in prison. Okay, he's in the prison bars. This guy's outside the prison, and as most of us know, people outside the prison cannot interact with the people inside the prison. Okay, so that's simplified, and that's my answer. Okay, now if I'm ever in doubt, I can just plug all the stuff that I have encircled there in parentheses, into the calculator, use parentheses, and you can get a decimal. Then you go back and you look at the original one, 3 divided by the square root of 5, and you see what that decimal is. If you come up with the same decimal, then you've done it correctly. Now, again, the whole idea is that we're trying to simplify it. And I got to tell you, this one here, the 3 times square root of 5 over the 5, it looks more complicated than this fraction. But see, it's breaking that rule. You cannot have any radicals in the denominator. Okay? So I'm going to look at the next one. I'm going to multiply times my special 1, where the thing in the denominator gets canceled out. Now that's going to become a pretty big number on top. It's square root of 150. What I think I'm going to do, well, I'll go ahead and do it that way. I could break out and simplify the square root of 50, but I think I'm just going to do it this way. So I end up with 10 times the square root of 3 times the square root of 50 all over 50. Okay? Now I can simplify the top. I can go 10 square root of 150 over 50. Okay, certainly the 10 and the 50 cancel, and I'm left with the factor of 10 disappears. I have the 150 on top all over 5. Okay, so now that 150, I suspect there's some perfect squares like 25 that go into it. So what I'm going to do is I'm going to go and do that work over here. So I have the square root of 150, square root of 25, times the square root of 4, 5, 6. Okay, and that's because square root of 25 times square root of 6 is 150. This turns into a 5. So I have 5 square roots of 6. Let's take this and replace it on top. I have 5 square roots of 6 all over 5. The 5's cancel, and I have square root of 6. Now, I hope that you all agree that that is a much simpler way of writing all that mess. Okay, but it took us some time to get there. Now again, I went through that quickly. If that didn't make sense to you, then you need to go watch my radicals video or come in for help, of course. Let's look at solving this equation. So what we're going to do, since it's got a squared term, we're going to get the x squared on one side, the numbers on the other. So I subtract 3 from both sides. Take the square root of both sides. That will cancel the squaring on that side. And I end up with x equals the square root of 50. Okay? Now, this is not in reduced form. We need to reduce that. Square root, square root. There's a 25 hidden in there, and there's a 2. So that 25 turns into a 5. Square root of 2. So there's my final answer. Okay? That's working with radicals and simplifying. Okay, I want you to put me on pause real quick, and I want you to set up your try it page, okay? So this is the only way you're going to get credit for this try it page. This is going to illustrate that you've watched the video. So set up your page, put your title at the top, put your name and the period number over on the right-hand side, and just underneath the period, I want you to write the words, "I watched the video." Okay, and then when you get to the try it page later on at the end, then you can go ahead and just set up your problems. Make sure you put the pictures or the original information into your homework and then show your work. All right, so let's take a look. Pretty easy stuff. I can identify the right triangle and its parts. This is all refresher, so I'm just going to leave this video, the slide up. You can put it on pause and copy these into your notes if you need it. The legs are the sides that wrap the angle. They're the adjacent sides to the 90. The hypotenuse is the opposite side of the 90, okay, of the right angle, okay? All right, very good. Let's go ahead and move on. Okay, so Pythagorean theorem, basically a squared plus b squared equals c squared, with c being the hypotenuse, okay? All right, so here's a right triangle. So I want you to go ahead and put this together and see if you can come up with that missing hypotenuse. It's one of our I can statements. Put me on pause, come back and check your work. So I've set up my equations with y being on the hypotenuse, which is on the c side. So I've got that y squared term. To get rid of that, because I need to know what y is, not what y squared is, take the square root of both sides, and I end up with y equals 5. Next. So here's another problem, and so go ahead and do this one. This one you're trying to find the leg of a figure. Okay, I don't care. Name it what you want. Let's call it K. Put me on pause. All right, so I made sure that 6 was on the C side, or in the C spot, because it's the hypotenuse. Take the square root of both sides, and I got K is equal to 5. That's wrong, so let me fix that. That makes more sense. Take square root of both sides. I have K is equal to the square root of 27. Now we have to ask ourselves, is there any perfect squares that still go into that 27? And indeed, there's a 9 and a 3. Okay, so 3 times 9. 9 goes first because it's a perfect square, and I get 3 square roots of 3. Okay, 3 square roots of 3. Very good. So this is kind of a review of something we've done before, so I'm going to really skirt through this pretty quickly. Basically determine if something's a right triangle, acute, or obtuse. Remember, you always have to check to make sure that it's a triangle to begin with. Add up the two smallest sides, make sure it's greater than the third. If that happens to be true, then you can go ahead and use the Pythagorean theorem. All right, so example 9, is this right, acute, or obtuse? I'm going to start with adding the two smaller sides and making sure that they're bigger. Well, 6 plus 5 is definitely smaller than 12. So this is not even a triangle. I'm not going to waste my time. All right, let's go over and do number 10. This is 7 and 5. That gives me 12. And that's definitely greater than 8. Okay, so that's a good thing. That allows me now to use the Pythagorean theorem, converse, to see if in fact what kind of triangle this is. So I'm just going to add up the two smaller sides squared and wonder, is that equal to the 8 squared? Okay. All right, turns out that the side that is supposedly the hypotenuse is too short to go with these two legs. So that means it's acute. Okay. And to help you with that, here's your list. Put those in your notes if you need them to have them refer back to. Okay. All right. So the I can statement here is that you'll be able to write and say the 3 trig functions from memory. Okay. So this symbol that's right here, it looks like a circle with a little curly Q on top, is you speak that using the word theta, and it basically is the unknown angle. It's sort of like the x or the y. You know, that is, the x and the y are very commonly known as unknowns in the world of algebra. When we get into trig, this theta kind of is the holding spot. Instead of using an X and Y, which we can use, it's more common in trig to use this theta symbol. Okay, so it's basically a circle and then a loop like that. Okay, so these are the three trig functions you're going to need to know memory. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and tangent equals opposite over hypotenuse. All right, so hopefully you did looked up SOHCAHTOA. You could look up SOHCAHTOA. That's a hint to how to memorize these things. Also, if you pay attention to at the very end of the video, there's going to be a bonus. Okay, so after the homework, I'm going to pause on talking about the homework, and then there'll be a moment where there's dead silence, and then just after that, at the very end, there's going to be a bonus. Okay. And I'm actually going to put the bonus right here. Okay, so on a separate piece of paper, find out who or what SOHCAHTOA is and how this applies to the relationship of right triangles. Set up a paper using the template below. Okay, so you're going to set up your bonus paper that look like this. It's going to be on a separate piece of paper. You put it on the back of your homework. I'm not accepting it. Okay, so you're going to write bonus, SOHCAHTOA, name, period, and then you're going to fully explain to get full 30 points credit applied before the end of the quarter as a bonus. Okay? All right, there we have it. There's your homework. Okay? So you have to write down what the sine, cosine, and tangent are, and then fill out the rest of that information. Problem number 4 is a review problem. You can go back to the video for 5.2 if you want, or your notes to figure out how to set up that problem. Okay? Good luck, everybody. We'll see you next time.